students. Today we have Proposition 47, Book 1, 47, famous prop. Okay? In right angle triangles, the square on the side opposite the right angle is equal to the squares on the sides containing the right angle. So another way to say that is the square on the hypotenuse has a special word, is opposite the right angle. The square on the hypotenuse is equal to the squares on the sides. Okay? In right angle triangles, the square on the hypotenuse is equal to the squares on the sides. Pretty famous prop. I think it's called the Pythagorean theorem also. Okay, so let's come in here and look at the given. Here we have a triangle. And it's given that it's a right angle triangle. And there's squares on the sides of each of the sides. Okay, these are all squares. Equal sides and right angles. Thus it is required to prove that this square is equal to these two squares. To do that, I'm going to break it up into parts. I'm going to do it for this square. It's going to be equal to part of this. And then I'm going to do it for this square, which will be equal to the other part. So the two will be equal to the whole. Okay, so I'm going to prove it for this one over here. And then I have another drawing. It's a little bit bigger, but imagine that it's the same size. And then I'm going to do it on this side for this square. Okay, we'll add them together. For our bag of knowledge today, we're going to rely heavily on this proposition. If you don't know this proposition well, you got to go back and look at it. That in a parallelogram on the same base with a triangle and in the same parallels, okay, you see this? See the same parallels? And on the same base, that the parallelogram is double the triangle. We're also going to use from our bag of knowledge that if you have a line and two lines coming from it, forming adjacent angles equal to two right angles, those two lines themselves will be in a straight line. We're going to show that equals added to, we're going to use equals added to equals, the wholes are equal. And then we're going to rely on side angle side. Okay? So let's get cracking. Right now, let's prove it that this square is equal to one part of this whole square. Okay? We're going to do that by doing some tricks here. Let's see. Get our little blue marker. I'm going to draw from this point a line parallel to this line. That's another thing we have from our bag of tricks. Given a line and a point not on that line, to draw a line parallel to that given line. Okay? So here's a line, here's a point not on that line. Let's draw a line parallel to that line. Okay? Now I'm going to show you that this chunk is equal to this chunk. This area is equal to this area. Okay? All right, let's get... by the way, let's prove that this is in a straight line. Remember, when you have two lines coming from a point of another line, creating adjacent angles equal to right angles, they're in the straight line. It's given that this is a right angle because it's a right angle triangle. And it's given that this is a right angle because it's a square. Okay, so here you have a line, two lines coming from it, forming adjacent angles equal to two right angles. Right angle plus right angle equals two right angles. So this is in a straight line. That is to say, this whole line is parallel with this line because this is a square. These are obviously parallel. The continuation then of the same straight line is parallel to it, okay? So let's connect this point with this point. Okay? And let's connect this point with this point. Remember, we drew this parallel to this. Okay? Great. Now, you see these two triangles? This blue triangle and this brown triangle. Okay? So what I'm going to do is show that this big blue figure is double this, and this big brown figure is double this. And I'm going to show that this triangle is equal to this triangle. Well, if this is double this and this is double this, they're going to be equal to each other because doubles of equals are equals. So let's show that this triangle, see this blue triangle? sorry, that little bit right there is kind of ugly. Okay? Let's show that it's equal to this one with side angle side, okay? So, first let's get some equal angles. Okay, we know that this is a right angle because this is a square, and this is a right angle because this is a square. Let's add this to both of those angles. So a right angle is going to equal a right angle, then a right angle plus something of the same is going to be equal to it. So this plus this, that is to say this angle, is equal to this angle. Okay? So now look at this triangle. Side, angle, side, with this being equal to this. And side, angle, side, with this being equal to this. Okay? So let's do it this way here. We'll go side, angle, side, to side, angle, side. Okay? This being equal to this, and this being equal to this. Side, angle, side, equal to side, angle, side. Okay, we'll do that again. Long side plus equal angle and short side are equal to long side plus angle and short side. Okay, we'll do that again. This and this being equal, okay, and this being equal. So here you have this and this being equal to this and this, plus those angles in the middle equal. So now we have two triangles with two sides equal to two sides, and the angles they contain are equal. Therefore, those two triangles are equal. I'm going to do it one more time. Side, angle, side in this triangle is equal to side, angle, side in this triangle. Therefore, the base is equal to the base, the triangle is equal to triangle. So this triangle is equal to this triangle. But look, this triangle is on this base as this parallelogram is on the same base. And they're in the same parallels. And we know that parallelograms, in this case a square, on the same base with a triangle and in the same parallels are double it. So this square is double this triangle. Likewise, this parallelogram, look at this triangle here. It's on the same base with this parallelogram, and they're in the same parallels. Look at this triangle coming up to here. It's in the same parallels with this. So a parallelogram on the same base with a triangle and in the same parallels is double it. So this is double this. Okay, now remember, we proved that this was double this, and now this being double this. And this is equal to this. So doubles of equals are equal. So this is equal to this. Okay? Now over there, I'm going to do that again. We're going to show that this is equal to this. And then we're going to show, therefore, that equals added, let's do this right. Equals added to equals, the wholes are equal. So this is going to be equal to this plus this. That is to say, the square on the hypotenuse is going to be equal to the square on the sides. Right now we've just showed for part of the square on the hypotenuse is equal to one of the sides. Now let's show that the other part of the square on the hypotenuse is equal to the other square on the other side. Okay? So let's do the same thing. We're going to do the exact same thing. And this time we're going to do it in red because we're going to utilize red here. We're going to draw a line. Remember, given a line and a point not on that line, you can draw a line parallel to a given line. We're going to draw a line parallel to this line. Excuse me, I'm going to get in front of the camera here for a moment. Yeah, red. Okay? Great. Now, what we want to do is make a triangle that's going to be in the same parallels with this, and a triangle that's going to be in the same parallels with this. Let's show that this is in a straight line, because they won't be in the same parallels if this is two different lines. We have to show this is a straight line. Same thing, remember, when two lines are coming from a straight line, creating adjacent angles equal to two right angles, they are in the same straight line. So here you have a line and two lines coming from it. We know that this is a right angle and this is a right angle. So here we have two lines coming from a point on another line, creating adjacent angles equal to two right angles. So those two lines are in the same straight line together. Therefore, this whole line is also parallel with this, because this being a square, the opposite sides of parallelograms are parallel, obviously. So this is parallel to this, so this whole is parallel to this. Now let's make some connections. Okay. Great. And make some connections here. Did I do that right? Yeah. Okay, let's make some connections here. We'll draw connect here. Because again, we want to have a triangle on the same base with this parallelogram. Oops, I'm going to do that in red. Okay? So we're going to do the same thing. You got to now picture this triangle and picture this triangle. Okay? First, let's show that the angles are equal. So here we have a right angle. Right here. And here you have a right angle. Right here. So this angle is equal to this angle. Let's add this to both sides. Therefore, the whole, oops, yeah, that's okay. The whole here is going to be equal to the whole here. So this angle is going to be equal to this angle. Now look at this triangle. So in this triangle we have an angle equal to an angle in this triangle. Okay? Now, we're going to do the same thing. Look at this side is equal to this side because it's a square. And this side is equal to this side because it's a square. Well, look at this. This triangle, let me put this now in red just so you can see it better. Solid red. And I'll put this in solid red, make you see it better. Okay. This triangle has side, angle, side equal to, in this triangle, I'll make this solid red now. Solid green. In this solid green. Side, angle, side. Okay? Side, angle, side equal to side, angle, side. Therefore, the triangle is equal to the triangle. But look at this. This is in the same parallels with this green triangle. And it's on the same base, this parallelogram, this square. So therefore, this is double this. Likewise, over here, this triangle is on the same base with this parallelogram. And it's in the same parallels because this is extended here in the same parallels. So this parallelogram, as we proved earlier, remember? A parallelogram on the same base and in the same parallels with a triangle is double that triangle. So this parallelogram is double this triangle. But this triangle was equal to this triangle. And this parallelogram is double the other one. So doubles of equals are equal. So this square is necessarily equal to this parallelogram. But earlier it was shown that this square is equal to this parallelogram. And this whole parallelogram, that is to say this square, is made up of this parallelogram and this parallelogram. Okay? So if this equals this, and this equals this, equals added to equals, the wholes are equal. So this whole is equal to this whole. Okay, so again, I'm going to repeat that. Earlier we showed that this big square is equal to part of the square. And we just showed that this square is equal to the other part of the square. Okay, so equals added to equals the wholes are equal. So this whole square is equal to these two squares. And this whole square is the square on the hypotenuse. And these two squares are the squares on the sides, just like over here. This square is the square on the hypotenuse. And these squares are the squares on the sides. And we show that the square on the hypotenuse then is equal to the squares on the sides. Quod erat demonstrandum, which was to be demonstrated. So we know now, for sure, we've seen it with our intellect, thanks to the help of our imagination, that in any right angled triangle, the square on the hypotenuse is equal to the sum of the squares on the sides. Thank you. Bye-bye.